Bismillahirrahmanirrahim. Assalamu alaikum. I hope everyone is doing fine. We are going to resume this course, microprocessor and assembly language, via this online procedure. Before this coronavirus situation, we conducted our 2 weeks classes and covered significant portion of this course. I will try to provide you an overview of that covered portion in this lecture and try to extend some of the knowledge. So let's begin. Subject microprocessor of this course is Intel's 8086 and 8088 microprocessors. Both of these microprocessors have same microarchitecture. Now we come to a very basic question, and that is, what is a microarchitecture? Microarchitecture is basically a graphical layout which gives us the information about the various circuit building blocks which are used to implement the different software and hardware architectures implementations. In other words, it lets us know what are different components and how they are connected to each other within the microprocessor unit. Furthermore, what are the signals, pathways, and among them uh, with their specific direction. A very important feature that we discussed about both of these microprocessors was parallel processing. What is a parallel processing? It is a technique which is used by Intel's designers to improve the performance or simply to speed it up. Well, it is no more Intel's proprietary. This technique is implemented nowadays by so many vendors. Well, uh, let's learn how it basically increase the speed of a microprocessor. Let's consider you have a 4-bit processor which process 4 bits of information in one machine cycle. Now consider if we add an equivalent weightage processor along with it, what will happen? Won't it increase its speed? Yup, its processing speed will be double. That's very simple basic uh, advantage of parallel processing. But it is not the only way to increase the speed of microprocessor. We have discussed two other features that have been implemented by the designers to speed up the processing units. Can you recall it? Let me recall it for you. One of them is increasing the clock frequency. What will happen if you are going to increase the clock frequency? It will reduce the time which is used in one machine cycle. Thus, in given time, you can process more number of machine cycles. Thus, you can process more number of information. Uh, so, uh, by increasing the clock frequency of microprocessor, we will decrease the machine cycle, so microprocessor can given more number of information or more number of bits uh, in given time. But there is an upper bound on a clock frequency increase because crystal clocks are natural occurring and we can't make very high frequency oscillator uh, with a great stability on artificial basis. Well, that was one of the feature. So what was the other feature? Another feature which was very helpful to improve the speed of microprocessor was to increase the bus length or the word length. What is a word length? It is a number of bits which can be processed in one machine cycle by a microprocessor. So if we increase the number of bus length or the number of wires carrying the weight, which is usually referred as bus, we can increase the speed. But one cannot increase the word length without upper bound, because it is proportional to hardware size. Thus we can increase but up to certain extent, and beyond which this technique won't be very useful. So both of these techniques has certain limitations, while parallel processing's value remain intact, and it's most important technique to speed up the processing of a microprocessor. Implementation of parallel processing in 8086 and 8088 microprocessor is accomplished using two different microprocessors. One of them is basically bus interface unit and the other one is execution unit. These two processes makes two processes these two processors makes two processes totally independent, since they are now happening simultaneously. What are those processes? One of them is basically instruction fetch. What is the instruction fetch itself? It is a procedure during which information is being fetched in microprocessor from outside world. Information which is being fetched can be data provided by input devices or stored in memory, and it can also be instruction which is stored in program memory. Thus, this is the part of the processing where exterior devices are interacted with microprocessor unit, and this job is accomplished by bus interface unit. Second process is instruction execution, which involves decoding of fetched instruction and execution itself. Decoding refers to the translation that what this instruction is supposed to tell the microprocessor, while execution refers the response of microprocessor after understanding the instruction. This whole process is usually termed simply instruction execution, and this is job of execution unit. Since bus interface unit and execution unit are separate microprocessing unit, so they do not depend on each other while performing their own job. So both processes become independent and simultaneous occurring. This results in higher performance in terms of microprocessing microprocessing of information. In this slide, complete microarchitecture of 8086 or 8088 microprocessor is shown. One can clearly observe two parts of this microarchitecture separated by this dotted line. Left side portion of this architecture is execution unit, while the right side portion of this architecture is execution unit. Sorry, right side portion is bus interface unit. This slide concentrates only on bus interface unit and enlists the various parts present within it. This is 6 byte storage place within this bus interface unit and is normally termed as instruction queue. And here we come to the very first variation between 8086 and 8088 microprocessors internal architecture, and that is their instruction queue size. In 8086, the size of instruction queue is 6 byte, while in 8088 the size of the same instruction queue is 4 byte. Uh, these four orange boxes refers to four important internal registers which are known as segment register. Uh, we will examine them in details on incoming lectures. And this yellow uh, uh, box is instruction pointer, while this summing block is an adder which adds two input provided by uh, different internal registers and generates a physical address which is of 20 bits long. That is why this address bus is 20 bit long. This is the logical this one this is the logical control box which controls overall flow of signals over various buses within this bus interface unit. In this slide, we will try to alias the various jobs performed by bus interface unit. Very first point is the summary of everything, that it interconnects microprocessor chip with outer world. And here outer world refers to the various input-output devices or the memory devices. Bus interface unit is also responsible for every kind of for all the external buses operations, which include instruction fetching from program memory and as well as read-write process of various kinds of data towards I/O or memory devices. Bus interface unit is also supervises Bus interface unit also supervises each transaction of data and address on various buses for the execution unit. Bus interface unit is also responsible for address calculation of instruction stored in program memory or the address calculation of data operands relating to the data memory or I/O devices. This slide is going to address the implementation of pipeline architecture using the queue. Since we know that 8086 microprocessor, there are only 6 locations in the queue, and each of these locations can hold 1 byte of information. Thus, it allows only 6 bytes of program memory to be fetched into the queue. Since 8086 or 8088 microprocessors is 16-bit microprocessor, thus it allows to fetch only 2 bytes, and if there is a space of 2 bytes, then instruction queue starts uh, again prefetching of instruction queue. While the instruction already fetched in while the already fetched information present in the instruction queue is decoded and executed by execution unit, the simultaneously next instructions are being fetched, and that is the magic of pipelining happening to speed up the processor. That simple prefetch queue is operation uh, in the first in first out format, because very first fetched instruction is supposed to execute it first. There are times while execution unit is busy in decoding and execution, and it does not request for any further instruction from bus interface unit and the queue, and queue is also full. So bus interface unit does not go to fetch next instruction. In such scenario, there is nothing to perform for bus interface unit, and bus operations are happening, or in technical words, no bus operations are happening inside bus interface unit. and those durations of time are known as idle states. Now this slide enlists all the components present within the my execution unit. The very first content or the component which is present inside the execution unit is control circuitry. This is responsible for data flow and directions onto various pathways within the execution unit itself. The next thing is instruction decoder, and this is the piece of execution unit which is responsible for decoding or translation of instruction into machine language so that microprocessor understand what operation is supposed to be accomplished. The next thing is ALU, and it's very common and generally known arithmetic and logical unit. This is a binary operating device which performs Boolean or any kind of arithmetic operation on applied operands towards the input of ALU. The next thing or the next component within execution unit is temporary storage or temporary operand register. It is one of the internal registers which are used by microprocessor for the purpose of temporary storage. Here, one need to keep this thing in the mind that this operand register is not user accessible or programmer cannot access it. So we won't be using it for in any instruction while we want to program or while we are going to program this microprocessor. This specific slide deals with the responsibilities of execution unit. The very first job which is performed by execution unit is to assess the instruction which are fetched in the queue. Beside the instruction, execution unit can also access any information coming from data memory as an operand part of instruction. This operand part of instruction and its related concept which will be much clearer when we are going to deal with the instruction set. Another job of execution unit is decoding or the translation of instruction to develop the understanding of operation which is supposed to happen in the execution. Execution unit is also responsible for the generation of address in some scenarios and directly pass this particular address to bus interface unit so that it can perform read or write operations on generated address locations. One of the most important jobs is to govern overall execution of instruction as it is dictated by instruction translation. So far we have discussed about previous important topics which should be highlighted in our revisions. Before we proceed, I will recommend you guys to go through every basic concepts that we covered during our normal classes before lockdown situation. Along with this material, along with the material which is reviewed in this lecture. Let's proceed towards the new addition to our knowledge of microprocessor during this session. The new topic is software model of 8086 or 8088 microprocessor. Here we come to an important question that what is a software model? And to answer that question, let's recall what was the definition of microarchitecture. Microarchitecture was the circuit building block that implement the software and hardware architecture. Unlike microarchitecture, the software model doesn't provide the hardware structural interaction of various components within the processor chip. Rather, software model develops the understanding of software point of view of a microprocessor. We can further clear this concept by asking an inherent question that what is important to know for a programmer if he or she is interested to program the processor chip, and what can be avoided to reduce the burden of a programmer. So let's answer these questions. First of all, what is not important for a programmer, which is not supposed to be always in his or her mind while he or she is programming the processor? And we can list them as internal functions of electrical circuits and their interactions, hardware layout of components like pin diagrams of processor itself. So these are definitely the items which can be ignored by a programmer because they does not have anything related to the programming language. Now let's answer the question, what are the important things to consider for a programmer while he or she is programming the processor chip? And those are size of memory or the size of internal registers, because they are directly related to different data types which are going to use in programming language. Another important thing to keep in the mind for a microprocessor's programmer is IO address space, or input-output uh, address locations, and how those locations are generated using internal register, because the content of related internal registers need to be modified if certain IO device addresses are supposed to access. This slide, this slide presents the graphical representation of software model and illustrates its integrating component. We can see that there are three important parts. This left part or left side portion is microprocessor unit, and we will talk about all these registers which are inside this microprocessor unit in coming slides or in coming lectures as well. And there, here we come to the next important portion of software model, and that is the middle portion, and it says external memory along with its various segments. These memory segments are again very important for programmer understanding, and we will be going through their depth in coming lectures. And in the last but not the least, this third portion or the most right portion of software model is IO address space or input output address space, which is available for input output devices to get interconnected with microprocessor unit. This particular slide is only dedicated for microprocessor unit portion of software model, and in this portion every internal register is shown within the diagram, and we are going to see these internal registers in coming lecture in detail, because each of them has certain meanings for programmer. In this slide, uh, the dedication is basically the external memory available for programmer, which is the important part of software model. Here we can observe the minimum address, which is basically 0000 hex. It is 5 times 0 in hexadecimal, and the maximum address is this one, 5 times f hex. uh, well, how these addresses are generated, we are going to learn about it. Furthermore, we can clearly observe different segments of external memory, like code segment. Let me highlight them. This is the code segment, this is the data segment, that portion is state segment, and that the last segment is basically access segment. We will going to learn that these are not actually four segments when we are going to deal with the segmentation in detail. This slide presents graphical representation of I/O address space available within the software model, and it is third and the last part of this software model. We can clearly distinguish the address range here from the memory addressing, which was 20-bit long, while this I/O space is 16-bit address. Minimum address is 4 times zeros in hex. I can highlight it for you people. We can clearly see it is 4 times zeros in hex, and the maximum address is 4 times f in hexadecimal. So we can clearly distinguish or differentiate between the memory addressing and the I/O addressing. Memory addressing was 20-bit long, and this I/O addressing is 16-bit long, because each hexadecimal symbol is composition of 4 binary bits. This address space is available for various I/O devices which are going to interconnected with the microprocessor unit. In this slide, we are going to list some points to ponder, or some points to note down for a student of microprocessor. First point to note is that same software model can be applicable to various microprocessors belonging to different generation, because it doesn't vary from one generation to another generation. Second point, the same principle is not valid for internal architecture, for the microarchitecture of microprocessor, because it doesn't remain same for various generations. So once anyone is going to deal with the microprocessor in hardware, he or she need to know the exact architecture of that specific microprocessor. Before we go to understand the huge memory present in the software model, let's consider a very small memory to understand the address and relation to its relation with the size of memory. Let's consider the memory of 4 locations. We can see in this picture this memory location, or this memory has only 4 memory locations, and if we want to address them in the binary, since they are just 4 locations, we can use 2 binary bits, and the first address will be 00, the second address will be 01, the third address will be 10, the fourth address will be 11. We can calculate the total number of locations but just by raising these number of bits to the 2. Like here we have 2 bits in address, so 2 power 2 is equal to 4 locations. This calculation is quite simple for this small size of memory, but we are going to apply the same principle to the original 8086 microprocessor. Before that, let's consider that each of this memory location, or in this memory location there are 4 locations, and each memory location can hold 1 byte of information. So the total size of this memory will be 4 bytes, since there are 4 different locations, and each location can hold 1 byte, so there will be 4 bytes stored in the complete memory. So the total size of memory will be 4 bytes. Let's consider the original memory of 8086 or 8088 microprocessor. We can clearly see the address is 20-bit long. This address is mentioned here in binary. These are basically 5 blocks of 4 zeros, so these are 20 bits. So minimum address is 20 times zeros, and the maximum address is 20 times 1. So the total number of location uh, present in this memory location will be 1 million, because 2 power 20 is equal to 1 million. And since each, we are going to apply the same assumption as we applied in the previous slide. Since each location is and this is not assumption for 8086, it is the original truth of the 8086, that each location can hold 1 byte of information. And since there are 2 power 20 locations, means 1 million locations, so the size of complete memory of 8086 or 8088 microprocessor is 1 megabyte, because 1 million locations and each location can hold 1 byte, so there will be 1 million bytes stored in the memory, or in simple words, it is simply 1 megabyte memory. The minimum address is 00 hex. It is just represented in hexadecimal. Each of these 4 binary numbers is converted into hexadecimal, so minimum address is 5 times zeros in hex, and maximum address is 5 times f in hex. So this is the point where we conclude this lecture, and if you have any questions regarding any of the material covered during this lecture, note them down. We will deal with them in online session.